Okay, so now we're ready to start trying to write this function. Now, do people want to see the whole thing work from scratch, or shall I suck in max min and start from there? What did I call it? Get min dot s. All right, we'll get rid of that. So we're going to start with this implementation. Now I'm going to, as always, start out here with labeling these guys. I'm not going to put the ESP stuff. All right. Okay, now this function needs to be called something different, so now this part's the same, right? I'm still passing the integers in the load to things, right? Now I could load all the parameters here, but just to show you that you don't have to, I'm going to write this one so that I only load that pointer when I need it. Okay, we'll wait on that for a second, okay? So the first thing then is going to figure out which register holds the minimum, just like we did before. And the good news is when we figured that out, then the other one must hold the maximum, right? So we're going to figure both things out with the same if we've already got, right? So compare I2 to I1. If I2 is greater than, if I1 is greater than I2, go to I2 is, put the comment in the correct thing. Okay, so let's go down and write this one first. I2 is the minimum. Now I'm going to need to, so if I2 is the minimum, then I1 is the maximum, right? So the first thing I need to do is write, I'm going to make a comment to myself. Need to write, let's just say, star max p equal I1, right? That's what I need to do. Any questions on that, by the way? What I'm saying there? Okay, so now at this point I need a pointer, right? And I better not use I1 or I2 to load the pointer. You know, I can reuse the registers if I want, but I need both the values. One's the max, one's the min. So I better give myself a new register. So I'm just going to define pointer. So I've got one left, which is EDX, I believe. Let me confirm that. Yes, EDX is my last caller saved register. Matter of fact, I might as well just, instead of using a generic term, I'll use max pointer. Okay, so now I'm going to need to get the max pointer. And for now, anyway, I still haven't had to have a frame size. So I'm not going to bother with F size or anything else. It's not really safe. If I was in a hurry, I might actually go ahead and use F size, and it would just be 0 if I didn't need it on an exam. But so far, I don't need it, so I don't think I'm going to, so I'm just going to say no. So the first thing then is I would have to move L. Now, the thing to remember about pointers is whether they're pointing to an integer or they're pointing to a double, the integer itself, the pointer itself is always an integer type, right? And on a 32-bit ABI, pointers are definitionally 4 bytes in size, right? So anytime I'm loading an address in a 32-bit ABI, I'm going to use move L. Even if it's pointing to a double, right, where you would normally think of, but the pointer is always an address, no matter what it points to, right? All memory types, even an instruction pointer, right? The fact that it's pointing to an instruction doesn't change. It's really pointing to a memory address, right? Okay, so that's why I'm using move L here. And that address is at 12% ESP, and I move that into max P. So now I can put a comment. Max P points to variable controlled by Now, okay, so now I have loaded now the pointer, so I now know where in memory this stuff is stored. In this case, what I've really loaded is to EDX, I've loaded the value 20 in this example, right? Which is really that address. So now what happens is, let's see, I use EDX, right? Max P, also known as EDX. Before this move, it was just a register, didn't mean anything. After this move now, I've moved the address, and so it is actually pointing to wherever that is, whether it's, whatever place that is in memory, okay? And we'll see in a second, we'll write the tester for this, so we'll see how we call this, so you'll see how that address gets initialized, okay? All right, I've got the pointer now, so now I need to write to the pointer. So let me write what I want to do first. I want to say star max P equal max, which is another way of saying equals, in this case, I2 is the min, so I1, right? That's what I want to do. So I'm going to say move L. We'll see why in a second. We're going to just write move for now, and we'll go fix it. I want to move I1 to what that thing points to. Now notice I'm not going to put max P here, because I want star max P, right? So that wouldn't work. Question?
Shouldn't be capitalized. Capitalized.
Well, you're right. And that is, it's case sensitive. I was looking at my label instead of looking at my declaration. Now, but this would not work, right? Because what this would do was overwrite the address with that. It would not change anything in the caller's memory, right? So the caller would not know that I attempted to change that guy. So instead, of course, I'm going to write, and now what I'm doing when I put those parents around there is say, this register is really a pointer, right? So write to this location. Just like we read ESP, you're reading the stack, right? The simplest thing is just, the register already holds the address I want. You don't need to add anything to it like we were doing here. So just store this value to that address. So what's really going to happen now, and now at this point, this is not valid simply because I'm now writing to a memory location, but I haven't told it how many bytes to write. Okay? So I'm going to now add, this is an int. Now, before, when I loaded the pointer, I said, I didn't ask how big the data type was. I asked, it's an address, so how big are pointers, right? Here I'm writing the data to this stuff. So what I'm asking is, how big is the data type? The data type is an int, so it's the same length as a pointer, so it's 4 bytes. But now let's pretend I was doing a double, like a float, but a double. Well, then I would have to write 8 bytes, even though the pointer itself is still 4 bytes, right? You point to an address that has 8-byte data in it with a 4-byte pointer. So in this case, it's the same. So I'm just going to add move L. And like I say, it's incorrect if I don't put the L on this guy, since this is not an all register operation. And so what that actually does is this, right? And so what's actually going to happen now is this will now go to his stack frame, and it's going to write I1 in there. Okay? Now, I move I2, so I1, which is the max has now been saved, where the caller can store it, can look at it. Now, I2 is the min. I don't need to write it to memory because I'm returning it in EAX as a return value, right? So I'm just going to leave that like that. Okay. So now we have the min is set, the return value is set correctly for both sides, but this guy is still lacking the max, right? We haven't written that out. So in the case, if I run the tester now, I'll pass some parts of the test when this is true. In the other one, I would get the correct answer for the min, but the wrong answer sometimes for the max, right, when I took this side. But now I've got to fix that side too. And now, what I could do, of course, let's write it, I guess we'll go ahead and write it that way. Now, I'm not going to put this above the thing, because I want it to happen only when, in the other case now, let me put a comment here. If I reach below here, that's just a comment for myself. Now I could put this here. Now I've loaded the max pointer, and then I could operate on it as we did before. But seeing that I need it in both places, I might as well move it up to here. Then I can get rid of it out of there. Right? I just showed you could do it anywhere, because sometimes that'll help you not use up all your registers. Right? You could do it only at the end in that way. But in this case, since I need it in both places, I might as well do it at the top. Right? Okay, so both of them can already assume they've got that. Now this case, all I've got to do is write the reverse of what I wrote below. Right? In this case, below my comment here. So I1 is the min, so I'm going to move I2 I don't need that because the percent's in my CPP, right? If I did it the way I just tried to write it, it would be %%, right, which would not work. So that is writing it to, and now it's a memory location, so I have to put the L there. All right, so my comment, max P equal I2. And I don't have to change I1, so I don't have to do anything. So that should be it. Now let me look at it and see if we've got the obvious errors here. So I'm first going to we already checked this, but I want just to give you a first look. Do I have the .text? Okay, good. I've got global. The name matches the name of the function, which we don't have anymore, but get min max. Let's make sure that I didn't reverse it. Get min max, okay, so we've got the name right. We've got a label with the global, and then the label itself. We've loaded the parameters, right, which match the comment we had showing where they were. This is where, if we actually allocated a frame, we'd have f size plus this, so that when we subtract, we still get the right stuff, right? Because when you subtract, you move that down. Okay, so that all looks good to me, so let's try to compile it. Anybody notice any errors before I try? Okay, so the assembly is correct. Now, let me cheat a little bit. Did I bring a test for this? No. Okay, well, let's adapt this test then. Copy O1 test.c to O2 test.c. So we'll just use the same basic idea. Now I'm going to change how I do this a little bit. Okay, so now when I make this function call, I want to pass something for the max pointer. And what I'm going to do is the ampersand of max. Now what has really happened is the compiler, just like you as an assembly writer, has allocated space for that max. And like normally, maybe the compiler would want to assign that max only to a register. But once we take the address of it, there's no address for a register, right? And so it is forced to allocate a local stack frame and store max somewhere on it, right? Otherwise it cannot pass an address that someone else can change. So what's going to happen is min will just get changed by reading the register in the return value, this guy will actually be directly changed by the assembly code, right? The assembly code will change this value itself, right? And it is illegal for it to do it because I've passed it a pointer specifically for that value. So let's now, yeah, I'll call it the same. We'll now put min and max. You got a question?
You need to change the function call. Is that getting in there now?
Oh yeah, we need the right name, right? I believe it's getting in max, right?
Yeah.
And now, unlike assembly, C needs to know the functions if you want to avoid weird errors. So let's prototype the function for it. And by the way, when you prototype the function, it doesn't care about the names of it. This is legal too. This is a legal prototype. Int star. Right? Okay, so that should be right now. Let's try it. GCC M32-W-all-C O2 test. Okay. So X test, I'll call it the same thing again. Okay. So any questions on that? And so that's a fundamental thing, is to know how to do pass by address, and it doesn't really change. In our first assignment, someone passed you a array of characters where you wrote the alphabet to it as a string, right? And the difference between an array of characters and a string is really just that the string is null terminated, right? A string in C is an array of characters with 0 meaning stop reading this thing. You'll notice that every other thing, when we have a vector, we always pass the length, or in other words, an array, one dimensional array. We always have to pass in the length, but you don't have to for strings, because you have to scan through to define it, right? You can't know until you look through the string how long it is, right? And so a string is just a pointer to an array in there. So here we have a pointer to one value, but pointers work the same with an array, right? An array is just, in some senses we've talked about the stack being an array of arguments, storage locations, but the difference is, unlike an array, every element can be a different data type. Well, an array, a pointer can point to an array, and now you've just got, the only thing is they're all of the same size, each element size, right? So you index it by moving through the bytes, as we described before. So pointers can point to any memory location. The memory location can be an instruction, it can be an array, it can be a variable, right? What we've done so far is passing it as a variable. Okay, all right, so now let's try to write a little more complicated function, and for that I think I brought a tester, that's the wrong tester. Okay, let me look at the tester first. I'm going to write now a function that corresponds to this guy. We're going to write assembly this guy, right? Get the maximum and the minimum, but now instead of only comparing two things, we're going to pass in a length for an array and an array its size. We're going to look through them and we're going to return the minimum value found in that size as well as the maximum value, okay? So our arguments now are going to be the length of the array pointer, and max peak. Now notice,
He's dead, Jim.